Oh, baby, it's just less than 8. Nothing to get scared about. Look, we're still writing equations with the constant of proportionality here. All right, it's all going to be good. So let's see what we got here. So lesson number 8. All right. Remember, proportional relationships have a constant, or in other words, a unit rate. So remember, those are our words that we want to make sure we're comfortable with. Constant, unit rates, constant of proportionality, all the same people that's there. All right. And then remember, to find it, we're going to do our y divided by x, which is our constant, which is our constant of proportionality. So here we go. Let's see here. Do we have enough gas to make it to the gas station? Good question there. All right. Your mother is accelerating on the interstate, beginning on a long road trip. You notice that the low fuel light is on, indicating that there is a half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage. Wow, good mom, keeping everything written down that's there. All right. So we're going to see is, hey, can we make it? All right. So remember, we need to come up with our constant. And to find our constant, we need to do y divided by x. So again, we just can't always just grab the table and be like, you're first, you're second, so you're x and you're y. Remember, it's about the order in which things happen. So, what makes the car go? Well, the gas. So we've got to put the gallons of gas in the car. Once that's in, the result is that we can drive. So that helps me out with my x and my y. So, let's see here. We're going to do 224, and we're going to divide it by 8, and we're going to see what happens. Let's go ahead and reach for our calculator. 224 divided by 8, and we get exactly 28. All right. Let's see the other one. We've got 280 divided by 10. No calculator needed here. That's also a 28. And then the 112 divided by the 4. Again, we're doing y divided by x each time. I wonder if it's 28. I'm going to go with a yes. And sure enough, it is. The other thing I notice here is half of 224 is 112. Half of 8 is 4. So we should get the same number here. So, okay. So explain what it represents in this situation. All right. So we're not talking about clowns. We're not talking about penguins on an iceberg. We're talking that we can get 28 miles, all right, per gallon. And again, per meaning for 1, which is our unit rate, which is why we're choosing to use our constant that's here. So write our equation that will relate them there. There's only one equation, y equals 28x. All right. And then, knowing that there's a half a gallon left. Okay. So half a gallon left. So half a gallon, half a gallon, half a gallon, half a gallon. You can see the gallons are our x. So let's see what happens here. 28 times a half. So what's half of 28? Well, that's 14. So she can go 14 miles. So is that going to be enough? And, I'll be honest there, people. Normally we don't see math problems like this. Normally we have enough to make it. But man, they're going to be stranded on the side of the road. All right, better planning that's there. All right. So no, she's not going to make it, which is kind of sad, actually. Oh, my goodness. Well, days of cell phones there. Make a phone call, maybe. Yeah, anyway. All right. So let's see here. Using the equation found in part B, determine how far your mother can travel on 18 gallons of gas. So again, we're going back to our equation here of y equals 28x. And we got 18 gallons of gas. We go back into our chart. The gallons were the x. So yeah, we're going to take our 28 and we're going to multiply it times our 18. That's there. All right. 28 times 18, 504. So we're going to be able to go 504 miles. All right. Using the concept of proportionality and then using the equation found in part B, determine how many gallons of gas would be needed to travel 750 miles. Okay, and again, this is why we kind of like this a little bit. All right. Dogs in the car. All right. That's really what's got me nervous. Not only are they not going to make it, but they got the dog that's with them there. All right. So y equals 28x. All right. How much gallons go to 750 miles? We saw the miles was our y from our table, and that's why we like to label our table up top there, because we can go right back up to it, and we can plug it in, and then we're solving our one-step equation that's there. So 750, and we're going to divide that by 28. Divided by 28. Oh, all right. So 26.7857. So when we talk about gallons, we're at the gas station. We're typically rounded to the nearest hundredths, to the hundredths position that's there. So I get a 26.7857, yada, yada, yada. So I'm going to go 100 sets here. I'm going to look to the right, and we are. So it's here 26 and 79 hundredths. 26 and 79 hundredths gallons of gas. I would ask, I would tell you if we need a round or something like that, rather than your gas mileage is probably limited. That's there when it comes down to it. You're not really pumping gas at the pump too much, are you? Probably not. All right, anyway. Okay, so that's what we're after here. What we like about this next question here is because it gets into our graphing that's here. So we do want to keep in mind that with our graphing, we do use the order of pairs x and y. And it helps us right away to see who the x and who the y is. Now, we can only grab points that are perfectly clean. So, for example, you are, all right? That's a good one to grab there. If I went to the right one, I don't know exactly how far. I mean, it looks like 1.5. I'm not sure, though. So we can't make that assumption that's there. So one of my points is the order pair 2, 3. Okay. I got to find someone else that works here as well. And the next person, there we go, 4, 6. All right. Then if we kind of see table-wise, times it by 2, times it by 2. So I feel pretty good about it. And we got to find someone else. There you are, which is to the right 6 and then up 9. So again, we could see table-wise, we're doing some repeat addition that's here. So write several ordered pairs in the graph and explain why each of the ordered pairs means in the context there. Okay. So we do want to keep in mind, so the 2 is on the x-axis. So we say for every 2 hours, all right, 3 portraits can be made. And then the idea here is we would just replace it. For every 4 hours, 6 portraits can be made. For every 6 hours, 9 portraits can be made. Oh, hey now. So that's kind of it. So write several equations that would relate them. Okay, well, we know our constant is y divided by x. So we use our graph and we can see that, oh, there's our x's. X's is our time, all right? The y is the portraits that's there. So when I look at some of these here, all right, I'm going to have a 3 over 2, all right? I'm going to have a 6 over 4, which simplifies to 3 over 2. I'm going to have a 9 over a 6, which again simplifies to a 3 over 2. So determine the constant proportionality and explain what it means in this situation. Okay, the constant here is 3/2. Again, all of these simplify down and explain what it means in this situation. Okay, so we can do 3 portraits in 2 hours. And again, when they're saying about in this situation, that's what we're after. All right. Oh my goodness, people, they're making announcements here. I got to get going there. All right. It's not something that you got to do. Bye.